All right, last time we talked about drawing a line of best fit. There's a much easier way and a much more accurate way to do this. It's called linear regression. This is lesson 7.7. So let's look at some data. This is some data of some trilobites. Nice big table there listing all the different kinds of trilobites. And so what I'm going to do is I'm going to use my statistics editor on my calculator and enter that data into two columns. And then just do a linear regression like I did a couple of lessons ago. You'll see that A, which is going to be the slope, that's going to be 0.63548. You'll see that B is going to be 2.50980. That's going to be your y-intercept. So that means that what we call the least squares regression line has the equation y equals 0.635x plus 2.51, and that's just rounding that a and b to 3 significant digits. If you want to keep them more accurate, please do. That, of course, makes all of your answers after this point much more accurate as well. So we talk about interpolation, talking about any combinations of length and width that aren't in the chart. So if I use that, I can find those x's and y's depending on what I'm given. What would be the width? So that's my y. What would be the y value if the length, that's my x value, was 8.5? So I use my equation, I plug in my x of 8.5, and I solve for y. Y ends up being 7.911 millimeters. And then if it was the other way, if I'm given a y of 8.5, then what would be the x value for that y value? So I replace y with 8.55, or sorry, just 8.5, and I solve for x, and I get that x is 9.426. And the same thing works for extrapolation. Now I'm dealing with lengths and widths that are either much smaller or much bigger than the ones that are in my table. So I use that linear equation again, and so for example, what would be the width, the y value, if the length, or the x value, was 3.5 millimeters? So I replace x with 3.5, I solve for y, and I get 4.734 millimeters. Same thing if I needed to solve for x. If I had a y of 20 millimeters, I would replace my y with 20, I would solve for x, and I would get that x is 27.523. So the process is very, very similar, whether you're interpolating or extrapolating from the data that you're given. So that is the lesson. If you have any questions, please let me know, and I will see you tomorrow.